Hello, this is Mrs. Koch, catching up on our notes from before spring break, and we'll be talking about angle-angle similarity today, just waiting for the presentation to load. So similarity was something we talked about with dilations, and if you'll recall, similarity is when two shapes are the same shape, but not necessarily the same size. If they're the same shape and the same size, we call them congruent, and if they're the same shape but might be bigger or smaller, then they are similar. So here's the angle-angle similarity theorem. It says if two angles in one triangle, oops, that's a typo, are congruent to two angles of another triangle, then the triangles are similar. So you only need to know two angles in both triangles. And why is that? Well, because the triangle sum theorem, which says the three interior angles in a triangle sum or add up to 180 degrees. So if you know two angles, you can solve for the third by adding those two known angles together and subtracting from the total of 180. So here's a example. We've got two triangles. We want to know if they're similar. Well, if we just look at them, we see we've got this angle is 110 and this angle is 110. So those two top angles are congruent. Excuse me. But it looks like the other two angles, well, they don't match up. We have the right angle on this one is 33, and we have the left angle on this one is 37, and those are not congruent. So it looks like they only share one angle, 110, typo there. So let's find more information. We're going to use that triangle sum theorem to find the missing angles. So 110 and 37 is 147. See if you can find that third angle by subtracting. 180 minus 147 is 33. So it actually does turn out that the right angle that's missing here is the same as the right angle that's given in the other triangle. So the two triangles are similar. But just to be thorough, let's find our missing angle here. 110 plus 33 is 143, and if we subtract by 180, we'll get 37. So according to the angle-angle similarity theorem, which is abbreviated AA similarity, the angles are similar, which means these triangles are exactly the same shape, just different sizes. Now here's an application of the angle-angle similarity theorem. Because the triangles that are similar are proportional, or they're the same shape, so all the sizes match up in a proportional way. So in this picture, we have a flagpole. We don't know how tall it is, but we know there's this 4-foot tall signpost. And this line right here is the sun hitting the flagpole and hitting the signpost and then the ground. The shadow of the flagpole is 30 feet tall and the shadow of the signpost is 6 feet. So the two shadow triangles are similar because they both have the same angle of the sun and they're both perpendicular. The flagpole is perpendicular to the ground and the signpost is perpendicular to the ground. So that means the ratios of the sides are the same. The proportions of the sides, or the sides, are proportional to each other. So I'm going to set up a proportion. 6, which is the shadow, over 4, the signpost, is equal to the shadow, 30, over the flagpole, which is x. And when we have a proportion, which is two ratios that are equal to one another, you can solve by cross multiplying. So 6 times x and 4 times 30. 4 times 30 is 120. And when we solve this one-step equation by dividing, I think we'll get 20. So our flagpole, in the context of the problem, our flagpole is 20 feet high. And that is one application of angle-angle similarity, because if you know that two shapes are similar, their sides will be proportional. And that's it for today. Have a great day.